Hi everyone, good morning ladies and gentlemen. My name is Odar Festo, a student of Kampala University, offering mathematics and ICT education. Today, I want us to look at a very fascinating problem, and that is integration, where we shall be using the factor formula. But advice, I would say, for you to be a good student of integration, you have to really integrate knowledge because we have several methods of integration, of which some you have really looked at. So, we should be able to know and recognize the different methods of integration because we have reached cases where one integration problem requires the use of 3 or more techniques of integration. For example, we are looking at cases of integration by parts. Therefore, the simple knowledge that we are accumulating will be very, very important. So every problem we are solving at one point will be combined to solve just a single problem. Yes, yesterday we looked at integration of the square of trig functions, where we looked at a problem like the cos squared x with respect to x. Now, there is no way we can integrate this problem straightforward. That's why we looked at integration of the square of trig function from compound angles. We looked at a very important relationship where we said that cos 2x is the same as cos squared x minus sine squared x. So in this case, the problem given is a cos squared x. Therefore, we have to eliminate this by changing it into a cos squared x. But remember, we know that sine squared x plus cos squared x is equal to 1. Actually, that's from circle. Remember, we also say that x squared plus y squared equals to 1. That is in a circle. Therefore, I can make sine squared x to be equal to 1 minus cos squared x. So if that makes sense, then we can actually substitute this into this, so that we have cos 2x is equal to cos squared x minus, actually I want to open the bracket straight away, plus cos squared x. So we collected like terms and we got 2 cos squared x minus 1. So if we bring this side, we shall have cos 2x plus 1 equals to 2 cos squared x. Then we try to make cos squared x a subject, where we realize that this implies that cos squared x is a half of cos 2x plus 1 all in bracket. Therefore, we went ahead and now integrated this. This was our problem of yesterday. So if we now apply the integral here with respect to x, is like integrating cos 2x with respect to x plus integrating it with respect to x. So this was our problem of yesterday, and we realized that when you integrate this, you get 1 over 4 sine 2x plus a half x plus that. That's what we looked at yesterday. But today, we want to look at what we are calling the use of factor formula. What is factor formula? A factor formula applies when we have the product of two trig functions. For example, if you have the integral of cos 5x, cos 2x with respect to x, this involves the use of factor formula. Remember, we say that cos A plus cos B, this is what we are calling the factor formula, is the same as 2 cos A plus what we're calling the product of two trig functions. Therefore, this is what we're going to generate and relate with what we are given. So according to this, we want something that looks like this, so that we can integrate this and integrate that. Therefore, what we do, we can say that let A plus B out of 2 to be the bigger angle, which is 5x. Say that A plus B becomes 10x. Call this equation in 1. Then for the smaller angle, because we're getting difference, this result gives us a smaller angle, and that will be 2x. Also, A minus B out of 2 will be equals to 2x. So that A minus B gives us 4x. Call this equation in 2. Now from here, we want to find the value of A and B. We're going to use an elimination method. That equation 1 plus equation 2. So that's what we are going to do. Then let's add up. What's equation 1? It is A plus B, then plus A minus B, which is an equation 2, will be equal to we have 10x plus 4x, we get 14x. So we can see this is the additive inverse, the positive b and negative b, meaning we can have a plus a, that is 2a equals to 14x. So from here we shall have a actually equals to 7x. Now, having known this, we can actually obtain the value of b from any of the two equations. So I will substitute A equals to 7x into equation, let me use 2. So equation 2 says A minus B is equal to 4x. So I will say A is actually 7x minus B equals to 4x. So from here, we can actually make B the subject, transpose this the other side, and transpose this, we realize that B is the same as 4 minus 7 minus 4, that is 3x. Therefore, A is 7x and B is 3x. Now from there, we are going to substitute in this factor formula. We can say cos. What is the value of A? The value of A is 7x plus cos. The value of B is 3x is equal to 2 cos. Now, this is 7 plus 3, 10 divided by 2, we get 5x. So let me eliminate the bracket, 5x. And this 7 minus 3, which is 4 divided by 2, we get 2 cos 2x. Now, this is where a teacher has made a mistake. We want to integrate cos 5x and cos 2x. So we have to eliminate the coefficient of these three functions. So what we do, we say this is a half into cos 7x plus cos 3x is equal to cos 5x cos 2x. And this is now where we are going to apply the integration. So we can take cos 7x plus cos 3x with respect to x is the same as integrating the original function given. The same as integrating cos 5x cos 2x with respect to x. Now, according to transitivity, we realize that the right hand side is equal to the left hand side. So we can switch that up. So that this right hand side is actually what we want. Therefore, integrating this and integrating this is actually the same thing. So let us proceed. You can proceed. So I'm going to switch. I'm going to calculate that integral of cos 5x cos 2x with respect to x is actually the same as integrating a half integral of cos 5x with respect to x plus integral of cos 3x with respect to x. Now, we can take the integration here. Now, from the compound problems, we realize that integrating cos gives us a positive sign. But what we do, we first differentiate the angle. Now, from the integration rule, we are going to say this is 1 out of 2 dot. That is simply go of this. You can say 1 out of 5. Sorry, we get sine 5x plus, when we differentiate cos, we get sine. So we can say, now we are going to open the bracket, that's 1 out of 2 dot 1 out of 3 sine 3x. Then we add the constant of integration. So this is what we are calling 1 out of 10 sine 5x plus 1 out of 6 sine 3x plus c. So this one gives us the integral. You can really understand that our main integration was here. The rest of the steps were to just transform the product into sum. And that can only be done using the factor formula. What are others? Factor formula. We should also be able to know that cos A minus cos B gives us a negative 2 sine A plus B over 2 sine A minus B over 2. Then we can put now the sine. We shall also know that sine A plus sine B is actually the same as 2 now sine A plus sine B is the same as 2 sine A plus B over 2 cos of A minus B over 2. And again now sine A minus sine B is the same as 2 cos A plus B over 2, and then sine A minus B over 2. So, as a teacher, you should be able to guide children through this from the knowledge of trigonometry. And they're able to master this, not cram. So, once you understand this, you shall be able to integrate any factor, any product of trig functions. So this is a very good problem. We begin by relating this. We find the value of A. After finding the value of A, we try to plug in and we continue with our problem. So thank you very much. I will be making another video very soon to cover some other areas. And in case you have any query, drop in the comment section. In case you have any number that shall aid to you, drop in the comment section. We shall be handling it as soon as possible. Thank you very much.